The first clue lay hidden in the Apennine hills of central Italy. From the days of the very first dinosaur to the last, this whole rocky landscape was mud at the bottom of the sea.
This 1 metre of black shale was
something big enough to suck the oxygen from oceans right around the planet. It's now thought that the world's richest source rocks and the most prolific oil regions are largely the result of these episodes of near-global ocean stagnation, the so-called oceanic anoxic events. And there was another clue hidden in the rocks, the full implications of which are only now being teased out. Each oceanic anoxic event was linked to a super greenhouse world.
Now we know that the whole of the Jurassic and the Cretaceous was a warm greenhouse period, but there seem to have been periods or intervals of
what we find supporting evidence for high atmospheric CO2 levels as well.
If you look at these times, these oceanic anoxic events, they seem to correlate with intervals of excess volcanism. And these huge outpourings of lava would have vented sulfur dioxide and carbon dioxide, and of course the latter would have promoted global warming.
The lead-up to every super greenhouse and matching oceanic anoxic event was the same. So the critical question for us becomes, how much carbon dioxide does it take to trigger such dramatic changes? That answer can be found in the ancient plants and their descendants still found growing today, like the amazing ginkgo.
Here we have, and essentially these probably formed a major component of the diet of dinosaurs through the Cretaceous and Jurassic. If you compare one of these modern leaves with a fossil ginkgo leaf, they're almost identically the same. And so by looking at the structure of this leaf and the chemistry of it and the fossil leaves,
4 or 5 times more CO2 than our pre-industrial levels gave you seas so warm you could swim at the South Pole. But don't think of the planet during a super greenhouse as one big tropical paradise. This was a world dangerously out of kilter. As temperatures go up, so does the rate of evaporation and the humidity. The obvious result was more rain, falling heavily in powerful tropical storms. The rain, when it came, would have been more acidic than today, burning vegetation and etching into the rocks and soils. This probably explains the sudden flood of plant food into the ocean.
So huge amount of warming, huge amount of evaporation, lots of clouds, lots of rainfall, swollen rivers wending their way down into the ocean, bringing sediment, but also bringing nutrients like nitrate and phosphate, the sort of things.
Such a flood of nutrients and the plankton blooms it triggered might have been enough to begin an anoxic event on its own. But in a super greenhouse, the overheated oceans were already primed for stagnation. Today's well-ventilated oceans rely on the planet having ice at the poles. It's here that warm, salty water flowing up from the tropics cools down, takes on oxygen, and sinks back into the depths to begin the return journey. This is the engine that drives ocean circulation.
The ocean mixes itself on the order of every 500 years or so. The supply of oxygen depends on there being cold water there. Warm water doesn't hold large amounts of oxygen in it, and so to provide oxygen to the deep sea requires cold waters where these deep waters are sinking.
In the lead up to a super greenhouse, there was no cold water at the poles. With both faltering currents and over-fertilized surface waters, the stage was set to push large areas of the global ocean, first into runaway anoxia, and then into something far more dangerous. Remove all the oxygen from the water, and deadly poisonous hydrogen sulfide will start to spread upwards from the stagnant depths.
There's evidence.
This is what was so special about the major episodes of oil formation. The oceans were dying from a double whammy of suffocation and hydrogen sulfide poisoning. And for as long as sulfur bacteria thrived in the sunlight, many other life forms faced extinction. This was a world with the entire seafloor stagnant and littered with corpses. Whole coastlines stinking of rotten egg gas and death. But here's the twist. Carbon has been buried to cool the planet. The burial of excess carbon resets the Earth's thermostat. There is a sharp drop in sea temperature, a drop in sea level, and signs of ice reforming for a time at the poles. And the legacy for us? Another oil deposit entombing all the carbon that caused the problem in the first place.
We find the oil, we burn the oil, we push carbon dioxide back into the atmosphere, and essentially we push the planet towards a greenhouse future.
Of course, crude oil is only one source of the fossilized carbon we're adding to the atmosphere.
If you look at the historical records of the atmospheric CO2, you can see us
It's global warming, but the next super greenhouse. The evidence suggests that the overcooked worlds of the past were triggered by levels of CO2 about 4 times higher than those at the start of our industrial age. Thousands or even millions of years to achieve these levels. We're on track to reach
Natural processes by 100,000, 10,000 times. So
no one knows at what point we might cross a threshold that switches us into real climate trouble. The guesstimate the world is banking on is that we can escape catastrophic change if we can stop CO2 concentrations from more than doubling. But this assumes there are no surprise amplifying effects waiting in the wings. And it's clear from warming signals in the Arctic, change can be unexpectedly rapid.
Much of Greenland has changed rather dramatically, much more dramatically than any of us would have thought 10 years ago. In about 2000, the glacier began speeding up and is now flowing at about twice the rate it was in the mid-90s, which means it's now putting out something like 50 to 60 cubic kilometers of ice a year, which is going to have an obvious impact on sea level rise.
It's this sudden loss of polar ice, both from the land and particularly from the sea, that has the potential to amplify warming and nudge us more swiftly into a hothouse future. As temperatures rise, there is less shiny white ice left to reflect heat away, and more dark Arctic Ocean ready to absorb it. The faster the sea warms, of course, the quicker the remaining ice melts. It's the sort of feedback loop that could help flip the switch on ocean circulation, and perhaps set the stage for the next major phase of ocean stagnation. Already, scientists report signs that the Gulf Stream has begun to weaken, and in late 2004, part of the current actually shut down for 10 days.
We would like to be able to conclude that these types of consequences are just buried in the distant geological past, but in fact, at least the early stages of widespread oceanic anoxia is where we're probably heading with fossil fuel burning. In terms of
As the human population climbs towards 7 billion and the desire for first world affluence spreads across the globe, we're burning oil as fast as we can pull it out of the ground.
Cars and suburbs and roads and that whole...
The thirst for crude is pushing civilization simultaneously towards two perilous futures. In one, the flood of cheap energy we've taken for granted will dry up faster than we can adapt. In the other, our headlong rush to use the last of the resource could plunge us into an unpredictable climate catastrophe. On the face of it, you might expect that running out of this stuff will at least save us from the climate threat.
The latest work of the climate science
pumped from its hiding place beneath the Arabian desert, our carbon atom is once more half of the Earth's endowment of crude lies underground, waiting for the human race to suck it up.
Our whole civilization has evolved in an era of stable climate, which is probably anomalous.
Oil is a precious thing. Fossilized sunlight captured by tiny, brainless organisms that lived for a mere instant in geological time. Yet every year we burn more and more of what we have less and less of. Are we mining the aftermath of past climate catastrophes simply to engineer our own? It would be ironic indeed if the end of our oil age becomes the start of the Earth's next great phase of oil formation. One thing is clear, love it or loathe it, we've all become part of oil's extraordinary story.